Good evening. Oh, sorry for the noise. Yeah, a little bit impromptu live stream. I hope you can hear me good. I've I had a bit of a hiatus on the live streaming, so I don't know if the setup is still as it should be, if I'm too loud or too silent. I'm I sound good to me in my headphones, so it's probably fine. So what are we looking at today? In the last weeks, I did lots of stuff regarding cartridge startup in the slot 0 core, which is the factory default MEGA65 core and the first slot of your QSPI flash. And this is responsible for doing all the startup logic, picking which core to start, and then handing off the work to some other slot and some other core. And you can't really exchange it because it's your lifeline. And if you don't have a JTAG, breaking your slot 0 is probably some sort of let's call it a soft prick, because it is a soft prick because as soon as you have a JTAG, you can start your MEGA65 again. Or I even had people sending me in their boards so that I can revive them. So that is why we are working on some way of being able to replace slot 0 without a JTAG and without all the danger of breaking something you need a long time to get it running again. Lots of background noise. Okay, so perhaps I turn down the levels a bit. So it does not sound so good for me. What about this? Is it better? Hi, Mark. So let's switch to some other view. I've still got the... there it is, the MEGA65. Hi, guys. Okay. Oh, I just saw that I can't insert a cartridge with the camera tripod leg right there. Okay, no problem. We can work around it. So let's see. How do we start? To do a bit of slot 0 flashing, we will need some core to flash. And then we need to extract the thing. Let us see. MEGA65 R3. I probably have lots of them. It was number 17. Okay. And then we have a core file, but we don't want this core file because that's still built with the old bit to core. I need a new core file, so let's build that. And the new bit to core, it's also a version I committed just yesterday. So bit to core. So then we build a core. I should not have pressed tab. We need the bit stream. We need to call it MEGA65. We give it some version. I always take this part. Let's add the file. And then we must tell it how it should be called. We call it upgrade core. And that's it. We could add some files, but I think that's enough. Okay, as you can see, there's one thing with the boot flags. We don't need some boot flags for the slot 0 core. This is the thing that makes the MEGA65 pick a slot depending if you have a cartridge inserted or not. And here's the CRC32 checksum calculation, which is then part of the core file. We can take a look at it. So it's 054C2333. And as you can see, there's the checksum, and this is the length of the core. And these two fields are needed so that the new upgrade mechanism or the new Flash program can validate if the core is loaded correctly into Etigram. So this is both of check if that what was loaded from the SD card has the right checksum, and it is also an Etigram check because the file is first loaded into Etigram and then the CRC is calculated from Etigram. So we are reading back, and so we see if everything that is inside the Etigram has the right bits set and not set. Okay, long talk. Let's put the thing on the MEGA65. Okay, I first need to, where's the MEGA65? Here. Here's the MEGA65. Let's put this over there and this over there, then you can see it. And okay, I have the dip switch set. Then we need to put this on the MEGA65. M65 put is a nice little alias I wrote myself so that it will delete a file securely and upload a file, and it can do it from multiple files. A small little helper I'm using all the time until I can use Etherlord, which I'm not. I did not come around yet to do it. I tested it 1 or 2 times and it works fine. Okay, yeah, leaning back. Yeah, if I turn my head to my monitor where I see my MEGA65, then I'm talking a bit away from the, or in an orthogonal direction from the microphone, so that is not so good, I guess. Okay, core is uploaded. Okay. Okie dokie. So how do we get the thing flashed? Currently this is still being done via JTAG, or you could do it with a UART only interface because you only need a serial connection to push the program to the MEGA65. You don't need to push a bit stream. The whole idea behind the new flashing is you make sure that you can boot your slot 1. Your slot 1 should have a MEGA65 core in it, and it should work. So how can we check it? Well, we can check it by looking inside the MEGA65. Okay, probably I'm turning my head away now. So I will switch off the dip switch 3. Don't do this with a metallic thing. Do this with a plastic thing, but I have none. Okay, and then I restart my MEGA65 with no scroll pressed. I get my nice menu. This is the new menu. As you can see, I have a core for a C64 core that has the C64 boot flag set. So if a C64 cartridge is detected, this slot will be booted and not slot 1. Oh yeah, I don't have a default core anymore. So, and what did I say? I will check if my slot 1 boots. So I select slot 1, press enter, and I can see, yes, my slot 1 boots. Okay, that's good. Now, the next thing to do, let me switch back to the terminals. And the next thing would be pushing the little helper which is currently called upgrade 0 PRG to the MEGA65. And then we can see, oh, there's lots of output and it's red, it's dangerous, and it tells me, oh, error, I can't access the QSPI flash. Dip switch 3 not set. Yeah, obviously, because we just switched it off. So let me switch it back on. Okay, then we boot up again. Now we get the funky screen and it tells us, you have dip switch 3 switched to on. This is not good because it's dangerous. So dip switch 3 is the thing that allows to the normal processor, the normal mode to access the QSPI flash. Normally only the MEGA65 in hypervisor mode can access the QSPI flash. But with dip switch 3 switched on, you can also access the QSPI flash with normal programs. So we press run stop, then we land in the monitor, which is some weird thing the ROM does. And now I can push my upgrade program again. Now there's nothing red, and I get the correct information of my QSPI flash. And now I can press any key to continue. Let's do that. And now we get some screen that tells us that we are about to do some bad thing. No, not a bad thing, but a dangerous or perhaps, yeah, a thing that should be done carefully. And it's the same with any other device you have. If your phone or your PlayStation or yeah, whatever device asks for an upgrade of the firmware, then most of the time it will tell you, don't turn the thing off while doing the upgrade, don't insert or eject a disk while doing the upgrade, don't touch the thing while doing an upgrade. And this is because while you flashing something, and if you interrupt it, then something can break. And there might be some ways to get it back running, but it is most likely a tedious process. So here's the same. Look that your slot 1, your slot 1 works. We did this. Then, why is that? Why do we need that? Okay, so if a slot is really broken, so there's some header in the bit stream that is in the slot. If the FPGA can't find this header, then it will go on and go through the whole QSPI flash until it finds this header. And if it finds a header, then it will start to load from this header on the information into the FPGA and program the FPGA. So if you have a slot that is broken in the middle, so there is the header, and then there's some information, and then there is garbage, then you will have the ambulance light, because it will load the thing into the FPGA, and the FPGA will have random stuff switched, and it will not work. But if the header is not there, then it will skip over all the stuff it does not recognize until it finds the header. So if we break the header, then it will skip over slot 0 until it comes to slot 1, and then it will load slot 1. So, and that is what the little trick the new flashing process does. The old flashing process did start at the beginning of the slot, erase a block, write a block, verify a block, erase next block, verify block, write block, and so on. So the header will be written first, and it will be there. And if the flash process gets interrupted, you have a broken core. So the little trick we do is we first erase the first block, so 256K in the QSPI flash, get erased first. And then I flash the slot backwards. I start at the end and flash the whole thing backwards until I flash the first sector I erased first. So this makes it that when you interrupt the flashing process, it will leave an empty slot essentially without the header. And then it should skip and find slot 1. So let's try this. As you can see, we must confirm with confirm. Let's type. And then the next thing, it will not give you the file chooser. It will just load upgrade 0.core. It will not look for anything else. So this is also a thing that is a bit of security. So you can not accidentally choose a C64 core for slot 0, which would also be bad. First, the thing is loaded into Attic RAM. Because this is running in normal mode, we get the nice speed information because the CIA is running. In hypervisor mode, the CIA is not running. Here we see the checksum that was written into the bitstream and the lengths, and it is calculating the CSE, which takes a little bit. Oh, sorry. Yeah, checksum is okay, and we can go on. So the next thing that happens is it will start flashing, and we will interrupt it. So I will switch off the MEGA65. Well, let me switch back here, and I will break slot 0 now. So now it is writing, and it has erased the first block. And now it's writing backwards. You can see it in the top. It's counting down, not up. And now we do the bad thing. We have a power surge or something like that. Okay, I just used the switch. And you see, I switched it off. Now I have a broken slot 0. And what happens now is I switch it back on, and you will see the ambulance lights. And now we need to wait a bit, because currently the FPGA or the some part of the chip, I don't really know which part it does, looks through the QSPI flash, and it looks for the header. And it will take about 20 to 30 seconds, because it needs to read all those blocks, and that is, it's booting slot 1. So I've broken slot 0. But it still boots because I have slot 1 still working. So now we can use the upgrade program again. Confirm the thing. Load the bitstream. So currently the flasher inside the core, which is the same program essentially, can't use the CIC32 calculation because it needs 1K of memory, which I don't have in hypervisor mode because the hypervisor is so big. Yeah, so I'm still searching for a solution to this. You can use the slot 0 flasher, and with the backward flashing, it should be safe, but I think the CIC32 calculation is an extra layer of safety. So probably I will see if I can find a place where to put the CIC32 tables, which I need only temporarily. So now it was a bit faster because these were the blocks it already wrote the last time. And it first verifies the data, and if the verification tells it it is the same data, then it won't write. And so it gets a bit faster. And now we are done. And as we can see, booting directly from slot 0, because we are not waiting 20 to 30 seconds till it finds slot 1. So that's the trick, and yeah, that's the plan for flashing slot 0. So now what is to do next? Yeah, I need to put this out so that people can try it and check if they find problems. So obviously this should be people that have a JTAG so that they can resurrect the MEGA65. Yeah, and if we when we have ironed out the bugs, and then yeah, perhaps got the CRC32 calculation also inside the course flasher, which might be possible. It has a lot of buffers, and perhaps I can consolidate them and use them for the CRC32 tables, because doing CRC32 on an 8-bit machine with only 40 megahertz is slow. And the way to make it faster is to use CRC32 tables. And this is normally the way it is also done on every other computer, because, well, 1K of memory is not much for recent systems. Only here is a problem, because, yeah, the space is limited in the hypervisor mode, essentially. Yeah, questions. Why is slot 0 now loaded? Should load 1 because you have a core there. Yeah, obviously. So the point is, this is actually, let me see, 5102. This is actually slot 1, as you can see on the checksum. So look in the line where there's is written git colon, and there is 2023 050102. So I made it yesterday night at 2 o'clock. And this is the core that is in my slot 1. I show it. So as you can see, there is the version 0102. And if we look at slot 0, you can do this by pressing help. Then you can see this is the other version. This is the version I put there. This is the core the upgrade 0 core I made just before. Where is it? In my terminal. Let me see if I can show it to you. Yeah, this is the version. So this is the slot 0 core. So the boot process, as I said, is first put slot 0. Slot 0 does nothing more than starting MEGAFLASH and using the OpenROM that is included in the core. And then MEGAFLASH, if no scroll is not pressed, so if no scroll is pressed, MEGAFLASH starts the menu. If no scroll is not pressed, then MEGAFLASH looks which core to boot. So the old process was look at dip switch 4 and then boot slot 1 or slot 2, depending on the setting of the dip switch. The new boot process is look if XROM or game are low, so if a cartridge is inserted. Look at the cartridge memory, which is always accessible at 400xxxx. So some high memory area. There you can always look at cartridge ROM and check if there are certain magic values in cartridge ROM. So because of that, I can determine is some cartridge inserted. And if a cartridge is inserted, then it determines what for cartridge it is. Is it a C64 cartridge? Is it a C128 cartridge? Or is it a MEGA65 cartridge, which has not been defined yet, how it looks like. I will do that soon, so that we can have Shodan 65 on cartridge. And this is then used to search for a core slot which has the flags set. So I did show you in the menu the strings at the end. So these are bits set in the core file. And most probably I will add a function so that you can edit these bits while in the flash menu. We will see. It's also a space dependent thing. And another thing that you can set is the default slot. So there's a bit that defines one slot as the default slot. So with the new slot 0 core, you are not dependent on the dip switch 4 to boot slot 1 or slot 2, but you can choose any slot to boot as your default slot, essentially. So I think I had my default slot at 3, but I have overwritten the core because I needed slot 1 to start. So that's a bit of the thing. If you have a default slot, then perhaps this one is started. And this might be confusing because if slot 0 is not there, then it will start slot 1 because there is nothing that tells it to load your default slot, because the FPGA is just rummaging through the slots to find anything it can put into the FPGA. Is that process you are explaining documented in the guide? Yeah, I think there is a flowchart, and I think the flowchart has some minor problems in it. And obviously I'm currently changing the process, so this needs to be updated, obviously. If it is out there, it is already out there, so you can download it. You can build all these tools I'm just using. Just make sure you have a JTAG. So don't break your MEGA65 if you don't have a JTAG. If you have a JTAG, it's hard to break it. I tried a lot and I did not manage it yet. So obviously with too much power and putting cartridges in the wrong way and static electricity and poking with a metallic thing on the dip switch block is also bad. So yeah, make sure you don't do anything electrical dangerous to your board. That can also be can always be a problem with any device. Yeah, but the idea is to make the boot process better and to make the flashing process better. So I'm in the flasher of the core. So if I power off again, press no scroll and power on. Now I'm again in the flasher, and I told you the slot 0 flasher is there. It is there. I can show you. If I now press the secret key combination, then it also gives me some short, old, notice that I should be careful of flashing. And if I now type the magic sentence, then I can flash anything into slot 0. And this obviously has also not the CRC32 yet. Perhaps I can get it in somehow. But I now could also, we just flash upgrade 0 again. You can see it also tells me upgrade 0 core, then it loads into Etigram. We get no speed information because CIA is not running, and so I don't have any timing information. I'm not sure if I can find a way around it. I could use the real RTC. We just saw there was no CRC check because no RAM for the tables, but it just flashes. And as you can see, it also flashes backwards. So this is no special flash mode in this upgrade 0 PRG. Upgrade 0 PRG is the same as MEGAFLASH. It's just compiled in standalone mode. So that is also one of the changes. Prior to that, we have had a MEGAFLASH.c, which was the flasher in the core, and we have had a JTAG flash.c, which was the standalone flasher. This is essentially gone. MEGAFLASH.c is both the flasher in the core and also the flasher that runs standalone, and also the upgrade slot 0 special flasher that don't has the file chooser and just flashes. So I essentially could, I can show it to you. We need to start up normally. Okay, so if I now use not upgrade 0, but mflash PRG, so I'm in normal mode, I'm not in the flasher, and I push the PRG and I get the flash menu. It just has different colors because the MEGA65 ROM has a different color palette than the Open ROM. And I have the flasher, and I could now flash a slot here. No problem at all. Let's do slot 7 and put something in there. Game Boy core. And we get the speed again because we are in normal mode. CIA is running. And we are flashing. And also this highest slot is flashed backwards. So all slot flashing essentially uses the save trick by flashing the first slot last. No, I need to start again. By erasing the first slot first, then flashing backwards and flashing the first slot last. So the slot is already written, and if there was some error while flashing, then the header is not there, and the FPGA won't find a bit stream in the slot. Okay. And now we have the Game Boy core there. And it's the same source code. So that's also a thing. So it was deliberate to split the standalone program and the core flasher, so that there's no thing that can flash your slot 0 in the core flasher. But essentially this made development harder because we had two different code bases, and you always had to change both of them, and it was not good. So now it's all done via compile flags, and while compiling you can tell which features you want to have. If you want to have those startup information we saw first about what the QSBI flash can do, we can look at it again. So this thing, you can make it more verbose. There's a debug flag with which you get even more information. So also while flashing, it will write all sorts of stuff onto the screen, which breaks most of the display. But if you're searching for a bug, then this obviously helps. And you won't have it in the release version. And this is all done via those compile flags. And now I need to add another version of the flasher into this combined code base. I need to see if I can get the CRC32 also in the core flasher. And I need some folks testing this. So I will be posting a test kit, I would call it, in the Discord, and then folks with JTAG can flash. So we also already had people that flashed slot 0 with this new core out of this branch, because this is what makes it possible that you can start up your MEGA65 using a Ultimax cartridge, which with the release core, the last all release cores will not start your MEGA65, but just stay where it is. So we can, let me see where I have a cartridge. Okay. Okay, I need this leg away. So, cartridge. Okay, this is a EasyFlash 1 CR. And it is now in Ultimax mode. And if I switch on my MEGA65, it should boot right into C64 core. Let's see. I press help. Ah, it's the C64 core. And it's, oh, eye of the beholder. Nice. Okay. So question, Sandcat. To get the latest flasher for the first time in slot 0, do we need JTAG? So yes, it is better if you have a JTAG. So this is working. You have seen I switched off the MEGA65 while flashing and broke my slot 0, and it still started. I did this multiple times in the last days, so it's, I'm quite certain that it works, and it is also a thing we did before in the past, so we did know that this is a thing. But I would feel better if you had a JTAG if you try it, because yeah, we need to iron out the bugs. And you only find those bugs if people start using it and testing it and do weird things. And because I have my method and my way of doing things, and I do it always the same way most of the time. And it's better to have variation. So perhaps people switch their MEGA65 on differently. Or you can see I have a VGA. I don't have HDMI. I also don't use the external SD. So this is also a thing. Oh, this is missing in the text. So you should not use the external SD card for flashing slot 0. So this is also a thing I need to add. Check for external SD card, and don't flash if there's an external SD inside, because the external SD runs over the Max 10 FPGA, and it makes things difficult. Let me put it that way. And HDMI, yeah, it's HDMI back power, and you don't want your system have different power inputs while trying to flash your MEGA65. That's not a good idea. Yeah. And this is why we need people who test this, who have a JTAG, who can resurrect their MEGA65, and who can tell us, yeah, there was a problem, I did that, and we need the information. What went wrong, and why did it went? Why happened it? What did you do? Did you have your child on your lap, and it the kid did press the keys wildly? This also happened. This is a real thing. This is how we found one of the boot problems. I think it was a gorgeous kid. Yeah. And then you can flash. So, and currently you must push the upgrade PIG. So this is what I meant by you need at least an UART so that you are able to use MEGA65 tool via the serial interface. So that would be possible. So if you are feeling dangerous, you have a UART interface, then you could flash your slot 0. But yeah, I don't know. It's your own risk, essentially. So if you're near where I live, or you can send your board to me, but this is nothing you want to do multiple times. Yeah, we also thought about we could set up a help network of people with JTAG interfaces. But the easiest thing to do is just go to the Trends web page and order a JTAG now. It's only, I don't know, 35 euros. And then you get one someday. And it's sooner than the web page tells you normally. And yeah, I think if you want to work seriously with your MEGA65, a JTAG is not a bad investment, essentially. But yeah, if it is something you don't think you need to wait till we have finalized the upgrade process and found a way to make it really solid. And I guess we are on a good way to make it solid. So essentially, it could be soon. And then we need to find a way to upgrade all those slot 0 cores of the people that have no JTAG and have the old cores in their slot 0. So that will be an interesting challenge, I think. Perhaps it could be something with Etherlord. I don't know. We need to look at it. Yeah. Any more questions? If it is really needed for the new flasher. Yeah, currently it is really needed. It is needed to push the upgrade PRG, because loading it from, you can also show this, because I thought that this should work, but it does not. So I have the upgrade PRG. Mount. So I have a disk that has the upgrade PRG. The error is normal. I think I made a bad disk. This is better. Okay, but if I now go to C64 mode and load the upgrade 0 PRG, which will take a while loading normally from the disk. Then it will not detect the FPGA. So something messes up the, not the FPGA, sorry, the QSPI flash. So something messes up the QSPI detection or access. Probably the mounting, I think, because mounting is something with the hypervisor, and it might be that there is something that fiddles around with some bits, and then the program thinks it can't access the QSPI flash anymore. So yeah, this is a thing that could be fixed. And if this is fixed, then we can make a upgrade disk image you can put into your MEGA65. Then the upgrade core you need to put on your SD card. And then you would boot with DipSwitch 3, load the program from the disk image, and upgrade your slot 0. This would be the ideal way of doing it. And yeah, it's only this minor thing I need to find out, and I think there should be a way to do it. And then we have a process that works without the JTAG, if we are sure that it does not break. Yeah, so and that is why we need the testers. But yeah, I will be posting a package to the Discord, and then people can test it with a JTAG. So all of you who have a JTAG, please use it, try it out, flash the new core. Then you can play around with the new 64 core and cartridges, like Eye of the Beholder. Yeah, and I hope we have soon more cool features we can put in. So my main thing I'm doing more currently is the better upgrade process, better boot process, cartridge stuff. So also defining the MEGA65 style cartridge. I did work with cartridges in the past, but this is 30 years ago. So I need to relearn all the stuff, how cartridges work. And I'm on a good way, I think. And then we can make some sort of cartridge. Perhaps I put first Mandelbrot 65 on a cartridge and see if I can get it running. And if I get it running, then perhaps I can put Showdown 65 on a cartridge. And yeah, then we can write down how a MEGA65 cartridge looks, and then publishers like Protovision can publish games on MEGA65 cartridges. I think this would be a really nice thing. Okay, I think I covered all the bases, and I wish you a good night, and yeah, until next time. And I hope I don't take as long as I did since the last video. Okay, bye.